All right, in number 9, we're finding the third term in the expansion of this binomial. Rather than trying to expand the entire 3x minus m to the fifth, let's look at a way of just finding the third term without having to find any of the other terms. So when you expand binomials, there's always 3 components to our term. There's the coefficient that goes in front, there's the first term, which is 3x in this case, and there's the second term, which is negative m in this problem. Before we try to figure out the coefficient, let's see if we can figure out the exponents that go with the 3x and the negative m. We know it's the third term and the total is n equals 5. And we also know that when we do binomial expansions, the first term starts at the exponent that's in the problem, starts at 5, and decreases down as you go through the problem. So if we're on the third term, the first term would have been an exponent of 5, second term would be an exponent of 4, and then the third term would be an exponent of 3. So 5, 4, 3 would be the exponent for this first term. We know that these two need to add up to 5, so that means this exponent is a 2. Now to find the coefficient, we're just going to use factorials. The numerator is the total exponent, so 5 factorial, and then the denominator is these two, so 3 factorial, 2 factorial. Now our goal is just to simplify. So if we simplify this is 5 times 4 times 3 factorial. The 3 factorials end up canceling out. Here we have a 27 x cubed, and here negative 1 squared is a positive 1 m squared. And then over here we have a 5 times 4, 20 divided by 2 is 10. So if I replace that with a 10, 10 times 27 is 270 x cubed m squared. So that would be C. All right, on number 10, which equation is equivalent to this log equation? We know that to change a log equation to an exponential equation, this base ends up being the base of my exponent. The n is the exponential, or the exponent, and a is what goes on the other side. So w to the n equals a. That would be option B. And then on number 11, which of the following is a solution to the system? When you're taking a multiple choice test, you can save yourself some time from having to solve this system from scratch. And let's work backwards and see which of the solutions work. So let's look at option A. If I plug in option A into here, negative x minus 4y minus 5z equals negative 22. So that's 13 minus 35 equals negative 22. That actually ends up working. Now plug it into plug option A into the second equation. Negative 4x minus 3y minus 3z equals negative 24. 26 minus 21 is not equal to negative 24, so I'm going to cross out A. Let's also try option B in the same system. So negative x minus 4y minus 5z equals negative 22. That checks. In the second equation, negative 4x minus 3y minus 3z equals negative 24. That also checks. And then the last one, negative 2x plus 2y plus 2z equals 2. That also checks. So we can see here that B is a solution. We know that it's not D because if it was infinitely many solutions, A would have worked as well. We know it's not C because there was a solution that ended up working.